In this section, we're going to look at counting atoms, or numbers that are associated with atomic particles. So first of all, we'll look at the atomic number, which is symbolized as Z. This is the number of protons in the nucleus of an atom. Now, the number of protons is set for a specific element. If the number of protons were to change, then you would have a different element. This is going to be equal to the number of electrons in a neutral atom. And the elements on the periodic table are organized according to atomic number. So when you look at the periodic table and see them listed 1, 2, 3, 4, 5 in order, those are actually the number of protons that each element has. I'll let you think on this one. Hello, darling. Do you have 11 protons? Isotopes are atoms that have the same number of protons but different numbers of neutrons. Now remember that neutrons don't have a charge and they're neutral, so the only way that they're really going to affect an atom is by increasing the mass. So for example, here we have hydrogen 1, which has a mass number of 1 because it has 1 proton. Then in the next one, we have hydrogen 2, which has a proton and a neutron. And then hydrogen 3, which has a proton and 2 neutrons. They all have only 1 proton, so that still makes them hydrogen, but they have different numbers of neutrons. So here we can see there are different names for those isotopes of hydrogen: protium, deuterium, and tritium. Now if we're looking at the mass number is the total of protons and neutrons added together in our atom. So for example, helium has 2 protons, so it's going to have an atomic number of 2, but if it has 2 neutrons, the mass number would be 4, because we would have the 2 protons plus the 2 neutrons. So here if we look at those isotopes of hydrogen again, protium with 1 proton would have a mass number of 1. Deuterium with 1 proton and 1 neutron would have a mass number of 2. And then tritium with 1 proton and 2 neutrons would have a mass number of 3. Now there's a couple ways to designate isotopes or symbolize them. We have the hyphen notation, which is going to have that element's name, the full name, and then a dash with the mass number. So hydrogen 3 or carbon 12. We can also have what's called the nuclear symbol, which with the nuclear symbol, you're going to have the symbol for that element, and then the number on top will be the mass, and the number on the bottom will be the atomic number. Now in this sample problem, we have sulfur 33, and it wants to know what is our atomic symbol. So we're going to need to use the periodic table. So I'm going to pull up this tab. We've got sulfur, which is a symbol of S, with an atomic number of 16. So I'm going to write S for my symbol. Our atomic number goes on the bottom, and then my mass number of 33 goes on the top. What about for nitrogen 15? So again, if we look at the periodic table, we'll find nitrogen. It is N and an atomic number of 7. So for nitrogen 15, we would write N, 7, and then 15 on the top. For hydrogen 2, hydrogen is a symbol for H and an atomic number of 1. So we would write hydrogen, 1 on the bottom and 2 on the top. Now if we recall, the atomic number was our number of protons. So our proton number here is 1. And if I needed to find the number of neutrons, I'm going to subtract my mass number and then minus my atomic number. So 1 proton and 1 neutron for this hydrogen. In the next slide, I'm going to look at what's called a nuclide, which is basically a different term for an isotope. Now, if we look at this problem, we're looking at how many protons, neutrons, and electrons are in chlorine 37. So if we look up chlorine on our chart, chlorine has 17 for the atomic number. So chlorine has an atomic number of 17. That's our number of protons. Our example said that we have chlorine number 37. That's our mass number. So if our mass number is 37 and our protons are 17, we'll subtract that to get 20, and those are our neutrons. Now what about our electrons? As long as this is a neutral atom and it doesn't give us any indication that it's not, our protons and our electrons will be the same amount. So if protons are 17, electrons will be 17 as well. What about bromine 80? So we're going to write bromine, and 80 is the mass number. So we need to find protons, neutrons, and electrons. Oops, sorry. So if we pull this up, bromine is number 35. So that's our number of protons. And again, our number of electrons as well. So then, to find neutrons, we're going to take the 80, subtract 35, and that's going to give us 45. In this sample, we're going to look at writing the nuclear symbol for carbon 13. So I will first need to find the symbol for carbon. And if I look on the periodic table, carbon is C, and it has an atomic number of 6. So my nuclear symbol is going to have a C with a 6 on the bottom, and then that 13, which is the mass number, goes on the top.